Alright, it's been 8 hours since last night that this vacuum pump was on these brand new hoses. I'm trying to bring down these new hoses. And if you remember yesterday, the other video I did on these hoses that are modified yellow jacket hoses, as you can see the size is much different. This is my modification. These were down to 54 microns, I believe, yesterday, and just within a few minutes. This has been 8 hours, and it could only get down to 59 microns. This is proving there's nothing wrong with the hoses. It's just that refrigerant charging hoses were never meant for deep vacuum. Okay, so let's turn it off. Remember, we're only measuring with the micron meter the volume that is in the hoses only. You can see they're attached here and they're attached here, so they're completely sealed off. So let's watch the micron meter. 59. Turn off the vacuum. There we go. You see how fast that moves? And that'll keep going up a few hundred microns. Now this is after 8 hours, well 8 hours from last night plus my hour and a half before, a total of 9.5 hours on the vacuum pump. And you can see the decay. Now, nothing wrong with the gauges, nothing wrong with the hoses. These are refrigerant charging hoses. They're not a vacuum rated vacuum hose. But you could see yesterday it was going up to like 900 microns within a minute or so. You see it's raising slower today because more moisture and more resins and solvents from the chemistry of making these brand new hoses have been removed. But still, it's going up, but much slower. Now I'm going to show you something else. We're going to attach it here and here like we did yesterday on these 250-pound tanks. So let's do this. Break the vacuum. And we'll attach it here. Now these tanks I put under a vacuum a couple days ago. And for these tests, we're back to zero. You see we're back to zero. Okay, now let's open up the vacuum. Now you see it goes down the vacuum very fast now. If you remember from the previous video yesterday that I released and I published, it took a while for the vacuum to go. It actually took, for these hoses to get down to 126 microns, brand new, it took an hour and a half to get down to 126 microns. We are now at 91 microns within 30 seconds. That's because after 8 hours of being on the vacuum, they have outgassed all the solvents and resins and the moisture and contamination of just the refrigerant hoses, and it took 9 hours of vacuum to do that. Okay, we're down to 81 microns. Now I'm going to open up this. Let's see what we got. See, it went down to 77 microns because the vacuum that was in this tank was lower than the 88 microns inside the hose. Now I'm going to open this one. So we're at 72. So now let's open this one. Okay, now I open that one. 69. Now we are at a vacuum that's lower than when the hoses were just attached to themselves. They were looped and attached to themselves. You can see we're at 67 microns. Now remember when I closed the vacuum and we were just the hoses only, it went over 200 microns of decay really fast. So now let's close the vacuum. Okay, closed. Now, remember it was over 200 or 190 microns really fast. It's getting there, but not as fast. And it's going to stable out and stop. So that's because there's now a large volume of a low vacuum compared to the off-gassing that these hoses are causing. These hoses are actually causing the micron rating to go up a little bit. And it'll eventually kind of stay there. Let's open this. Okay, this was also off and closed for the last 2 or 3 days. And it went up to 4,758 microns, point whatever. So now let's open this up. Let's see what it reads. $118, 117. Now do you see how this says 117? That's on the other side. That's not attached to the hose. Remember, this is on a dipped tube. There's a tube that goes all the way down. Let's get out. That goes all the way down to the bottom of this tank. On this one here, there's no tube. It's just right at the top. So these are not attached to each other in no way, but they just share the volume of the tank. 117 microns. 205 microns. That's with the vacuum off. These are at 2 different points. This is directly to the tank, 117 microns, and this micron meter is located at the other end of the hoses. Do you see how where the placement of your sensor for your micron sensor makes a difference of what you're actually reading? When you're using refrigerant hoses, it adds to your reading. It's a good way to learn, and it's a good way not to have to buy 2 pieces of equipment at the same time. So if you buy a set of gauges with a micron meter, at least you'll get a general idea of what's going on, even though it is not the correct way and it adds a little to your reading. When you buy an individual micron gauge and you hook it up to the system, and then you can turn off and isolate with a ball valve or some other method to isolate the system from the micron gauge. This is the only way and the only time you can get a true reading, and this is the only way you can get a reading that does not rise because it's caused by your hoses. So when you purchase a highly accurate digital piece of equipment that has a micron gauges, don't hook your hoses up to something like this and try to read just the volume of leakage through your hose, because it'll look like you fail, but you're not. Alright guys, I will see you later. I think that's the only thing I wanted to get through to you was that. That's it. So when you buy your gauges brand new, if you try to just leak test the small hoses all by themselves, plugged at the ends, it'll look like you're failing and like you have a leak. But you actually don't, because refrigerant charging hoses were never ever designed to hold a deep low vacuum. Alright guys, see you later. And this is why you want a isolated micron gauge attached to the system, totally separate from your hoses.